Okay, in this video, I'm going to show another trigonometric identity that we can prove with our parametrization. So this is going to be the sine of theta is equal to the square root of the secant squared theta minus 1 divided by secant theta. Okay, so in order to show this, we're just going to do the same thing what we've been doing. We're going to substitute in the parametrization functions. So we know that the secant theta is the inverse of the, the multiplicative inverse of the cosine. So 1 plus t squared divided by 1 minus t squared. That's going to be squared minus 1. And then, so remember, the cosine is the multiplicative inverse of the secant. So if I'm dividing by secant, I could just multiply by cosine instead. So I'm going to go ahead and do that. And that's 1 minus t squared divided by 1 plus t squared. So I just saved myself a bunch of steps and a bunch of space here because I could have divided by 1 plus t squared times divided by 1 minus t squared. I could have done this, right? I could have done 1 plus t squared divided by 1 minus t squared. But then I would just multiply by the reciprocal, which is exactly what that is. So I just went ahead and wrote it like that. Okay, so let's just make sure I'm in the right spot here. Okay, good. Alright, so for here, I'm just going to square that term on the inside of the radicand. It's going to be 1 plus 2t squared plus t to the 4th divided by 1 minus 2t squared plus t to the 4th minus 1, taking the square root of that, and I'm still multiplying it all by 1 minus t squared divided by 1 plus t squared. Okay. So from here I'm going to want to factor these two, the top and the bottom. And well, maybe it would just be easier if I just erase it and factor it. So 1 plus 2t squared plus t to the 4th is going to be 1 plus t squared times 1 plus, you know what? I just realized it was unnecessary for me to break it down into those terms. I should have just said 1 plus t squared squared and then 1 minus t squared squared. That's actually what I want. Okay, so forget that last step. We'll just pretend it didn't happen. 1 minus t squared times 1 minus t squared. Okay, I think that's actually what I want. Goodness, I don't have enough room here. Actually, I guess maybe I did want to multiply it out like that. Yeah, okay, never mind. I did want this multiplied out. So 1 plus 2t squared plus t to the 4th, and then 1 minus 2t squared plus t to the 4th. Okay, so this is going to end up being 1 plus 2t squared plus t to the 4th, and I'm subtracting 1, so I just have to make that into the denominator here, the same in the numerator and the denominator. It's just working with fractions. So minus 1 minus 2t squared plus t to the 4th plus t to the 4th divided by 1 minus 2t squared plus t to the fourth Okay, so this kind of proof probably isn't recommended here. I don't really know what the geometric proof looks like for this, but it's probably easier than this. But let's just continue on here. So that's 1 minus 1, 2t squared plus 2t squared. So I know I'm going to have a 4t squared. And then t to the fourth minus t to the fourth. So I just have a 4t squared here in the numerator, because those terms will be subtracting each other out. And then I have 1 minus t squared squared. So 1 minus t squared squared. Okay. So now that's what's under the radical there. And 1 minus t squared divided by 1 plus t squared. Okay, so you remember what the goal is? What we're trying to make this look like? Well, we're trying to make it look like sine of theta here, 2t divided by 1 plus t squared. Now, I don't know if you can see it yet, but I can already see how it's going to happen. We're going to take the square root of that, and we're going to end up having 2t there, and well, that's a square there, so it'll cancel. 1 minus t squared, and then we're going to be multiplying it by the fraction 1 minus t squared divided by 1 plus t squared. So those divide each other out, and I have 2t divided by 1 plus t squared. Okay, so that's exactly what we're looking for. So I've shown that we can use algebra to prove this identity there. Okay.